So in the last video, we took a look at this new theorem here, which gave us 3 additional shortcut rules that we are now able to use when trying to calculate derivatives, of really complicated functions. So in total, we have the constant multiple or the constant rule, the constant multiple rule, the sum and difference rules, and all the way back at the top, remember we have the power rule. So all of these now are able to be used, and we can use them whenever we are trying to take the derivative of the associated thing. So I'm going to go down here and take a look at example number 4 to try to see how we can use a lot of these rules all together. Let's see what we would end up with if we started to calculate things here. So I'm going to start by jumping in and saying that if I wanted to calculate here the derivative of x to the 7th minus 22x to the 3rd plus 4x squared minus 6x plus the square root of 5, at first I would have a lot of work on my hands, but I can start to think about what rules I can use to help with this. Notice that one of the first things I might see is that I have a lot of things here being added or subtracted together. And the sum and difference rules tell me that if I ever have things being added or subtracted together, I can separate them into derivatives of individual pieces being added or subtracted together. So I might go ahead here and separate this out to look like the derivative of the first piece minus the derivative of the next piece, and then plus the derivative of my third piece, 4x squared, then minus the derivative of 6x, and then finally plus the derivative of the square root of 5. Okay, well, I have a lot more to simplify here. Let's see. In my first piece here, I can easily start to use a rule. I could recognize that I have x raised to a power, and so the power rule can be used to simplify just this piece. So to calculate this derivative, I could bring 7 to the front, leave the x, but lower the power. Okay, great. So that first part's finished. Now how do I calculate the derivative of this part? Well, notice that I have a constant being multiplied to another formula. So this might be a good time to use something like the constant multiple rule. 22 is kind of like playing the role of c, and my x to the 3rd is kind of playing the role of this f of x. And so I could take the 22 out and just focus on the derivative of that x to the 3rd. So I'll write that as 22 times the derivative of x to the 3rd. Notice I can do the same thing with my 4x squared. I can take the 4 out and leave the x squared on the inside. I'll just multiply the 4 on afterwards. I can even do the same thing over here to what's happening with my 6 and my x. However, this last derivative here is actually a super easy one, because notice that square root of 5 is just a number, which means it's a constant. And the derivative of any constant, no matter how ugly or simple, is always 0. So this piece I can immediately replace. Now I can continue on by simplifying out all of the rest, or calculating out all the rest of these derivatives. So let's see. I have 22 being multiplied by, and let's take the derivative of this piece. Derivative of x cubed, I can tackle with the power rule. That's going to get me 3, and then x squared. The derivative of x squared is going to get me 2, x to the 1st. You don't have to write that power of 1 up there if you don't want to. The derivative of x to the 1st, remember, is going to get me 1 times x to the 0. 1x to the 0. Remember, though, that x to the 0 is just going to be 1. And so if I simplify everything down here, will have 7x to the 6th minus 22 times 3 is 66x squared. 4 times 2 is 8x to the 1st. And here I'm really just going to have minus 6 times 1, or just minus 6. And I won't even bother to write the plus 0. So here we are. I have my derivative. Now, normally, throughout the rest of the semester, we're not going to show the application of each individual rule so slowly like we did here. It might be a good idea for you to try to do that in your first couple examples, but typically we're going to be able to try to almost jump right from where we started the question, almost right to the answer. But making this jump can be a little bit challenging at first, and so it might be helpful to try to write things out slowly, one line at a time. Now, it's definitely the goal of this course to try to be able to jump right from the beginning right to the end. And by the time we get to exam 2, it's going to be super crucial that you're able to calculate derivatives with roughly that kind of speed. For the moment, don't worry if you need to write the steps, and I encourage you to write as many steps as you need to try to make sure that you're understanding these rules and how they're implemented.